हेलो स्टूडेंट्स। बच्चे लास्ट टाइम हम लोगों ने बात करी थी इलेक्ट्रिक डाइपोल की एंड व्हाट एन इलेक्ट्रिक डाइपोल इज। इलेक्ट्रिक डाइपोल इज अ कॉम्बिनेशन ऑफ इक्वल एंड अपोजिट चार्जेस सेपरेटेड बाय अ सर्टेन डिस्टेंस। लेकिन आज के इस टॉपिक में हम लोग बात करेंगे हाउ टू फाइंड द इलेक्ट्रिक फील्ड ऑन द एक्सियल लाइन ऑन द डाइपोल। फाइन। So before I can proceed with this article, I will let you know, I will recapitulate the things. Let us suppose this is an electric dipole. According to definition, electric dipole is pair of equal and opposite charges which is separated by a certain distance to a, right? अब मेरे पास एक्सियल लाइन कौन सी होगी? कौन सी लाइन को बच्चे आप एक्सियल लाइन बोलेंगे? द लाइन ज्वाइनिंग द टू चार्जेस, मतलब माइनस क्यू और प्लस क्यू को जो लाइन आपकी ज्वाइन करे और उसी लाइन को आप फॉरवर्ड प्रोसीड कर दें तो इस लाइन को बोला जाता है एक्सियल लाइन। ओके, इट मींस अगर मैं इस लाइन को प्रोसीड कर दूं लाइक दैट, इफ आई विल जस्ट हैविंग दिस लाइन इन द फॉरवर्ड डायरेक्शन वेयर माइनस क्यू प्लस क्यू दे आर लाइन ऑन द सेम लाइन, तो ये वाली जो लाइन मेरे पास बनी इस लाइन को क्या नाम दिया जाएगा? This line is basically known as axial line. ये वाली लाइन बच्चे मेरे पास axial line होगी। Okay, so now I have to find the electric field at any point on the axial line. So for that let us consider this is any given point P where our test charge Q0 is lying, और ये मेरा वो ऑब्जर्वेशन पॉइंट है जहां पे मेरे को इलेक्ट्रिक फील्ड कैलकुलेट करनी है। ओके, so in order to find the electric field at point P, let us consider this is the center of the electric dipole and this center of electric dipole is represented by O. Now from O, let us suppose the distance of the observation point is represented by R. ये आपके ऑब्जर्वेशन पॉइंट और सेंटर ऑफ द डाइपोल का डिस्टेंस है। अगर आप अपने डाइपोल को टू इक्वल पार्ट्स में डिवाइड कर देंगे, then distance from this point A to O, that distance is represented by small a, and in the similar way distance from O to B, that is also represented by small a. Fine, so this is how one can evaluate now electric field. अब मेरा मोटिव क्या है? मेरा मोटिव है इलेक्ट्रिक फील्ड फाइंड आउट करना पोजीशन P पे, फर्स्ट ड्यू टू प्लस क्यू चार्ज एंड देन ड्यू टू माइनस क्यू चार्ज, और लास्ट में मैं इसका सम करूंगा टू फाइंड आउट द टोटल इलेक्ट्रिक फील्ड। मुझे पता है इलेक्ट्रिक फील्ड फाइंड आउट करने के लिए एक तो हमें सोर्स चार्ज चाहिए एंड सेकंड डिस्टेंस बिटवीन द सोर्स चार्ज एंड द ऑब्जर्वेशन पॉइंट, राइट? तो इफ आई एम गोइंग टू कंसीडर दिस प्लस क्यू चार्ज, सी दिस इज माय प्लस क्यू चार्ज, तो प्लस क्यू चार्ज से आपके ऑब्जर्वेशन पॉइंट P का डिस्टेंस क्या आएगा? व्हाट इज द डिस्टेंस ऑफ ऑब्जर्वेशन पॉइंट from this charge plus Q? See carefully, this is R and this is A, so this is equal to R minus A, right? And whenever I am talking about minus Q, so what is the distance of the observation point from minus Q? Now see carefully, this distance is R and I am going to add this A, so it means from position A, if I am talking about the distance, then distance is equal to R plus A, and this is the situation which we are going to now take care. So electric field at point P due to source charge plus Q, and then electric field at point P due to source charge minus Q, and then we are able to find the total electric field. So come, due to charge plus Q, I am going for the calculation part. So due to charge plus Q, सबसे पहले मैं कैलकुलेट करूंगा इलेक्ट्रिक फील्ड ड्यू टू चार्ज प्लस Q। Let us suppose this electric field is represented by E plus vector. Okay, by formula I know that electric field is equal to 1 upon 4 pi epsilon naught magnitude of the source charge। यहाँ पे सोर्स चार्ज आपके पास है Q, and what is the distance? Distance here is BP. So I am talking about the distance square. Here distance is BP square. Now see the direction. ड्यू टू पॉजिटिव, मैंने आपको पहले भी बताया था कि पॉजिटिव चार्ज करके इलेक्ट्रिक फील्ड लाइंस दे आर ऑलवेज मूविंग आउटवर्ड, व्हाइल ये वाला पॉजिटिव इस पॉजिटिव को रिपेल करेगा, तो पॉजिटिव इलेक्ट्रिक फील्ड जो होगी दैट इज मूविंग इन दिस डायरेक्शन एंड दिस इज रिप्रेजेंटेड बाय E positive, right? And this direction is known as x-axis. तो along x-axis we are going to use a cat. That cat is represented by I cap. Now I need to put this value Bp square. So electric field due to positive charge, that is plus Q. This electric field is equal to 1 upon 4 pi epsilon naught. It is charge Q divided by, see from the diagram, what this Bp is equal to R minus A. So this is R minus A whole square and multiplied by the direction. Direction is represented by I cap. That is along the positive x-axis. Fine. Now come to the second. Second is minus Q. Now my motive is to find the electric field due to minus Q. See carefully. Second charge is due to minus Q. That is second pole of the dipole. How to find the electric field due to minus Q? Due to this minus Q, electric field at position B, again we are going to apply the formula. Electric field due to minus Q is E minus, and this is represented by, that is equal to 1 upon 4 pi epsilon naught. It is magnitude of the charge Q divided by distance square. So here distance is represented by AP square. It means it is AP square. Now check out the direction. Direction is when this positive is moving towards the minus Q. See, this is negative, this is positive. So this charge is moving in the inward direction. It means electric field due to negative charge is moving along the minus x direction, and minus x direction is represented by minus I cap. So while solving this, electric field due to negative charge, I can write this E minus. So this is equal to 1 divided by 4 pi epsilon naught. Here I am talking about the source charge, that is Q, divided by AP square. See from here, this position is A and this position is P. It is R plus A whole square. So that is R plus A whole square. And now the direction is minus I cap. This negative is coming here and it is represented by I cap. This is my equation number 2. So this is the way by which I can evaluate electric field due to positive and electric field due to negative. Now how one can find the total electric field? According to the principle of superposition. When I am going to apply the principle of superposition, total electric field at point A, total electric field due to a dipole. So how we can evaluate this total electric field at point P? This total electric field at point P, that is represented by E vector. This is equal to electric field due to plus Q plus electric field due to minus Q. And already I calculated these values in equation number 1 and in equation number 2. So this is 1 divided by 4 pi epsilon naught, charge divided by distance square, R minus A whole square. Direction is represented by I cap. And in the negative, E negative, there is a negative sign. So this negative here, it is negative 1 divided by 4 pi epsilon naught, magnitude of the charge divided by distance square, R plus A whole square. Direction is represented by I cap. I need to solve this equation to get the total electric field at point P. So see, the total electric field at point P, this is E vector, that is equal to, so common from here is Q divided by 4 pi epsilon naught, and inside the bracket from here, it is 1 divided by R minus A whole square, and along with this negative sign, it is 1 divided by R plus A whole square. Outside I am talking about this direction. Direction is along positive x-axis. So this electric field, it is Q divided by 4 pi epsilon naught. I am going to solve this. It is A minus B, A plus B, means A minus B square and A plus B square. So this is A square minus B square whole square. It is a mathematical identity. Whenever I am solving A minus B square, A plus B square, it is A square minus B square whole square. And now I am going to solve this. See, while I am taking the LCM, LCM means this and this. These two things I have to write there. So negative, negative, this and this cancelled out. Here I left with r plus a whole square and with negative sign. Now r minus a whole square, that is only left. It is going to cancel out. So this is r minus a whole square. Outside I am talking about the direction. Direction is represented by I cap. Fine. So by solving this electric field, we are getting this electric field E vector that is equal to Q upon 4 pi epsilon naught. By solving this, it is a square plus b square plus 2ab 2ra, negative sign outside. Again, it is a square plus b square minus 2ab 2ra and divided by r square minus a square whole square. Right? R square minus a square whole square. While I am taking this negative inside, minus r square minus a square, and this is positive. So this is going to cancel out with this. A square is going to cancel out with this. So total electric field E vector in this case, it is charge divided by 4 pi epsilon naught. Here I am talking about the direction also. I cap. Right? It is 2ra plus 2ra, that is equal to 4ra I cap and divided by r square minus a square whole square. Fine. This is the electric field now. We are going to resolve it more steps, making it more easy, and whenever we are solving it, electric field E vector that is equal to, can I break this 4ra like that? It is 2a multiplied by 2r, and whenever I am multiplying 2 to 4ar, outside it is I cap and this whole divided by 4 pi epsilon naught within bracket, it is r square minus a square whole square. Now we know about this quantity. Since I am talking about the dipole, Q multiplied by 2a, this is equal to dipole moment, and dipole moment is represented by P. So here it is this quantity Q2a, that is P. P multiplied by 2r into I cap and divided by 4 pi epsilon naught. It is r square minus a square whole square. So finally we can write in vector. Electric field vector at point P. See, this dipole moment is the vector quantity. So I am taking this. It is 2r in the front and writing P vector at the back, which is going to define the direction of electric field. Divided by 2 pi epsilon naught. It is r square minus a square whole square. And this is first expression for the electric field due to axial line, or we can say electric field at a point on the axial line due to an electric dipole. We are just having one special case where we are able to prove that electric field is inversely proportional to r cube, right? So if I am going to consider that r is greater than a, so what I can write here, this r square is more greater than a square, and in this situation we can write r square minus a square, that is approximately equal to r square. So by using this in equation number 1, my electric field E vector that is equal to, it is 2r P vector divided by 4 pi epsilon naught. Here this factor is reduced, that is cancelled out. R square whole square, that is equal to r raised to power 4. So r and r cancelled out. It means it is 2p vector divided by 4 pi epsilon naught r cube. And this is final expression for the electric field due to an electric dipole. So this is my equation number 2. And what I am going to conclude from here, this 2 is constant, P is constant, 4 pi epsilon naught is constant. So I am having conclusion that electric field is inversely proportional to cube of the observation point from the center of the dipole, that is E is inversely proportional to R cube. I hope you people understood this article. In the next lecture we will talk about electric field due to equatorial line.